Every day, I am thoroughly impressed by what AI agents can do. For example, diagnose issues in my Kubernetes cluster. That's good. But I can also connect multiple services. For example, this Slack agent to be able to diagnose the problems and alert my DevOps team on Slack. So AI agents are simply LLMs with the power to call tools, think services and APIs, but when it comes to actually building and using agents, well, it might not be as easy. But I've been working on open source software for years at Red Hat, and in the next few minutes, I want to show you exactly how open models and standards like Model Context Protocol can help to build our own AI agent, starting from my local machine and using open models as well. So let's get started. Now, as you might know, open models have been quickly catching up to proprietary APIs, but we have full control of our data, the cost, and maintenance around the models that we want to use. And we're going to be using some models from Red Hat AI's Hugging Face repository, which has been pre-compressed to run at 2 to 3 times the throughput of their original release with less hardware requirements and almost maintain the same accuracy on benchmarks. So if we come down here, we can actually check out a specific model. For us, this is going to be Llama 3.3 and see that it's actually been quantized to floating point 8 precision. But if we go down here past how to use the model, we can see that the accuracy remains not only the same, but just a little bit better too. Now, in order to serve this model, I could use a tool like VLLM or Llama to serve this locally, or we can use a tool or a practice like Models as a Service to distribute these models to developers and teams around our organization. With this model ready, how do we actually connect it to our existing APIs and services like Kubernetes and our Slack workspace? Well, instead of writing custom code for each tool that we want to use, the open source MCP or Model Context Protocol standard provides a uniform way to pull data from various sources into the context window of our large language model. And MCP servers provide a list of tools and resources that the LLM can utilize, like listing pod logs in the namespace, adding a meeting on your calendar, or maybe a read-only view of your database, but there's countless MCP servers out there. Now today we're going to be using specifically the Kubernetes and Slack MCP for our application. To put this all together, we need a tool that can use our LLM and act as an MCP client, like the open source project Goose or another desktop application, or even something in our application like a framework or orchestrator. You'll notice here in Goose on the left, I've got an extensions tab, and I've added 2 different MCP servers, which are simply running as Node.js apps, but are using my existing credentials, for example, to log in with my kubeconfig. Now, they could be containerized as well, but here we're running them locally. On the right side, I've got my Kubernetes cluster, and I'm curious about the health of my applications. We're going to use Agentic AI to diagnose the past few builds and see what's up. Here I'm going to ask, hey, check out the past few builds for the Blackjack app deployment in this specific project. And what happens when we actually send this prompt to the LLM is that the MCP client is registering that we have those tools. It is telling the LLM that, hey, you can call these tools, and here exactly is how to do so. And we get that information back in JSON data, and the LLM provides this to me in natural language. So this is a really cool example of how to firstly diagnose what's happening in my cluster in natural language. But because this has gone well, we need to use another agent and pass this information along to our team. So here we're going to use another MCP server in order to pass this information along to our team here on Slack. So I'll ask, hey, let this specific channel know your findings and be detailed. So if we head over now to this channel on the right, our team is going to be informed of our AI agent's findings in our Kubernetes cluster. And you can see this information has been pasted along with all of the formatting for Slack as well. And that's just a quick example of how open models, along with an open protocol like Model Context Protocol, can be used to build agentic AI applications that connect to our various enterprise data sources. If you're interested in how Red Hat AI is supporting agentic AI for enterprise use cases, be sure to definitely check out the link in the description and let us know what you'd like to see next. As always, thank you so much for watching. Be sure to like the video if you learned something today, and we'll see you again soon.